Hello. Okay, if you're watching this, you're sitting at home watching me run code in Spyder, which is exciting. Good to see you again. Okay, now, we're going to come back to Spyder, so please reopen Spyder through the launcher. If you already have it open, please have it open. We're going to take a look at the other .py file in the code folder. So when you look in the code folder, we had the O2, the IPython notebook, so you can tell with the IPython notebook. What I'm looking at right here is called O2 files and weather. Files and weather.py. Just go ahead and drag that right into Spyder and you should see this. All right, so on the left we have our file, on the right we have our console, same as before. Now in this class, over 90% of the code that we run will be in Spyder. So if there's one thing you want to get used to, if it's IPython notebook for Spyder, for this class, get used to Spyder, because that's what we'll be using the most. All right, so now we're going to be looking at actual data from a data file. So like I mentioned, this data is actually alcohol consumption data from the World Health Organization. And just to kind of give you a sense of what that looks like, over here I have a link to it in the GitHub. If we look at the CSV, and does anyone know what CSV stands for? Comma separated values. You can think of it like a better Excel spreadsheet. The CSV is literally just text separated by commas. And in fact, it's very widely used in the computer science world that even when you render it, it looks like kind of what you would see in Excel. So here's what the data looks like. It's a bunch of rows and columns, which we're all pretty much used to. Now, to tell you what it means is the World Health Organization took a poll of as many countries as they could get their hands on, and they asked, on average, how much beer is these citizens drinking, spirits, wine, and the total liters of pure alcohol consumed by an average citizen of each country in a year. So essentially, the first is organized by country alphabetically. So essentially, in Afghanistan, Afghanistan is claiming that there is 0 beer serving, 0 spirit serving, 0 wine serving, and 0 total liters of pure alcohol consumed per citizen per year on average. As opposed to Albania. On average, in a year, an Albanian citizen drinks 89 servings of beer, 132 servings of spirits, and 54 servings of wine for a total of 4.9 liters of alcohol in a year. So that's the data we're going to be looking at today and also starting on Monday. So we're going to get used to this data for the next 2 days. So back to Spyder. The first thing that we're going to have to do is we're going to have to tell Spyder the directory that we're in. So you know how you CD, pwd in your terminal? We're going to now tell Spyder where we are. How do you do that? Up here in the top right, you should see a folder button. Click that folder button and your basic folder explorer will pop up. Navigate, normally, not with the terminal, until you are in sf.15 and then the code folder. So go into the code folder. You should see a bunch of grayed out files. When you see those grayed out files, you're in the right place. When you are in the code folder, hit choose. And then when you hit choose, next to the folder button, there is this Python icon. Click it. What we've just done is we've just told Spyder where we want to be working in. And I say where, I mean literally what folder. So you'll know if this worked is this line, which is line 11. And I'm not going to change the line, so when I say line 11, it should be your line 11 unless you change it. Line 11 says f equals open, and then there's a string. That string represents a directory. So what does dot mean?
Previous directory.
Previous directory. So where is drinks.csv? Well, we're in code. Go back a previous directory, which puts you in sf.15. Go into data. And then inside of data is drinks.csv. So if you're in code, this line of code should not give you an error. If this line, line 11, gives you an error saying, I can't find, file not found, then you did not properly set your working directory. If this line of code gives you an error, please raise your hand and a TA will come with you. Yeah. So if you guys can help out. If there is an error on this line, you did not set your working directory. Now, if it did, If it did, run line 12. Line 12 says f.read. F.read is going to give you all of the text inside of that file in one fell swoop. So here we're looking at a long string of all of the text inside of drinks.csv, and it's super messy. And if we hit read again, it's going to say, well, that was it. That's all the text there was. So if I keep hitting read, it's going to say there's nothing left. And that makes sense. Question? They shouldn't have to. Windows users should be able to hit folder and then Python, then be in the same directory.
Yeah, I think people might start not choosing the Python icon. And the second thing is, if you do PWD on that over there on the right side on your, yeah, it is really bad. Something useful to work.
Okay, yeah. And then line 14 will close the file. So we opened the file, we read everything inside of it, we tried to read more, there was nothing, and then we close the file. Period. So far, so good? Next line. We're going to open the same file. But this time, instead of read, we're going to read line. Read line will give me the first line in that file. The first line happens to be the headers, the column names. Country, beer servings, spirit servings, wine servings, total liters of pure alcohol, and then the continent that country is in. If we read line again, does someone want to tell me what they think is going to happen? What is the next line? Do you remember? It's Afghanistan. Afghanistan was 0 beer, 0 wine, 0 servings, 0 total liters of pure alcohol, and what does AS stand for? What continent is Asia? Yes.
Could you, inside the line, could you put a number to indicate the index of the row?
That's a great question, and the answer is no. Because the way this works is, it's called an iterator, which essentially means it has to go one after another. So it's like next, and then next, and then next, and then next. The thing is, what makes it better, though, is that, let's say you have a list of 1 million things. If you make a list of 1 million things, well, somewhere on your computer has to be stored 1 million things. However, if you go one by one, you never have to store 1 million things at once. You just keep storing the next thing, and then delete it, and then the next thing, and then delete it, and then the next thing. So this is a way to make it faster to read through a very large file. So you can't just go jump around, which is the con, but the pro is all you have to do is keep going one after another. And then finally, we'll close it again. It's very good practice to, if you open a file, close it, because you could accidentally delete it and you wouldn't even know, because when you open it, you're giving it free range of use in your Python file. And if you don't close it, if you close your laptop, something bad might happen. So it's always good practice to, if you open a file, close it. So we've opened the same file twice and then read it. Let's open it a third time. Now we've read it, .read. We've read a line at a time with read lines. Line 24 says f.readlines, plural. That will actually give you a list where each element in the list is the next row. So now with this list, we can jump around. But it's because we told it to make a list with read lines. Bless you. And then for safety, we'll close it again. So this is just us opening the file and reading it in different ways. Line 28 opens it a fourth time. Now, we're going to use a list comprehension. Row for row in F. This is actually the same thing as read lines. In fact, if you look at the code for read lines in whoever wrote the file operating system, it literally is a list comprehension that's row for row in F. It's just a list comprehension that just iterates over each row one at a time. And then we'll close it. Line 35 does the same thing. Line 35 and 36 rather. It just iterates through over and then does a list comprehension. And I apologize that I'm not going too deep into that, but I do want to get to some of the later stuff for lack of time. Okay. Now, with open, we can also split. So remember, if you look at the list up above, each row is not a list, but it's a string. Each row is a string, comma, or country, comma, beer service, comma, wine, comma, spirit, comma, total liters, comma, cotton. It's one single string. So in line 39 and 40, what it's doing is it's iterating over each row and separating the string by comma, which is why the CSV, the comma separated values, we know we can split it on comma because commas were used to split the values. So far, all we're talking about is different ways of reading data files, CSVs. There's also a module called CSV in Python. To make the open, the close, all of that easier, there is a module called CSV. So if we import CSV, we can actually use the CSV dot reader. So line 44 and 45 is the same thing using the CSV module. So using the CSV.reader. So to not, what's that? To beat a dead horse, right? To not do that, in real life and metaphorically speaking, I am going to skip down a little bit to writing to files. So we've read some CSVs, now let's actually make some files. So in these lines of code, 59 is going to make nums equals to range 5. So what will nums be? It's a list, right? So if I run line 59 and then look at nums in my console, it's 0, 1, 2, 3, 4. The list from 0 to 4. Now, I'm going to open nums.txt, which doesn't exist. But when I open it, Python will automatically create that file for us. So when I open the txt file, and WB stands for write binary, when I open it and call it f, for each num in nums, I'm going to do f.write the string num, and then I'm going to add an escape character. /n is how you actually write out enter, like hit enter. So whenever you see a /n, it's the new line. It's essentially the same thing as you hitting enter and going to the next line. It's a new line character. So when I run this whole thing, 59 through 62, looks like nothing happened. But if we go to our code, look at that, nums.txt now exists, and inside is 0, 1, 2, 3, 4. So now we've written to a txt file. Notice where it put it in the code, because that's where we told it to put everything. When we changed the directory up here in the top right, we said read everything from here, write everything to here, unless told otherwise. Line 65 creates another list, and inside of that list are two smaller lists. So output, its first element is the list, call 1, call 2, call 3. Output's second element is this list, 4, 5, 6. So let me actually ask you a question. What is the len of output? 2. There are two things in output. Now, what is output? What is the first element of output? The list of call 1, call 2, call 3. So what is the len of the output 0, 3? So output is a list. Inside of output are two more lists. The first list inside of output is call 1, call 2, call 3. The second element of output is a second list, 4, 5, 6. And I'm going to open my own CSV file called example. So open example.csv, call it f. YF file, it's just my own construction, doesn't matter. So I'm going to open it, and again, it doesn't exist, but as soon as I say open, it will create example.csv. So I'm going to open a CSV file. Then for each row in output, which there's only 2 things, call 1, call 2, call 3, and then 4, 5, and 6, for each one of those, I'm going to use my CSV writer and write row. So back to my Finder, I now have this new examples.csv, and if you look at it, it is, let me do this. If you open a CSV, it'll default to open in Excel. At least on my computer, I'm pretty sure it defaults on everyone's computer. And you can already see why we choose to use Python over Excel, because that took way too long to open 6 values.
Is anyone else seeing a name error?
If anyone's having an, yeah, no, that's fine. Please, no, please. If anyone's having an error running any of these lines of code, please raise your hand, and I'll stop the class and make sure that we're all on the same page. So now you see, I wrote each row, call 1, call 2, call 3, and then 4, 5, and 6. So throughout this course, we'll be reading and writing CSVs. Yes? Yeah. Say again, I'm sorry.
So I guess it automatically will separate cells.
Good question. Yes. So the question is, how does it automatically know where to separate it? Because in the list, call 1 is the first element, call 2, call 3. Each element is its own cell. Yep, each element is its own cell. The quicker way to do it is to use the CSV module and just write rows and then give it a list. And this will make the same exact CSV. Okay. Now that's all well and good, and the reason I kind of rushed through that part is because starting on Monday, we're going to be introducing another module that reads CSVs and writes CSV even quicker and easier. But I just wanted to get you accustomed to the idea of how to change your directory and then where the files all live. So from now on, we'll be working in this directory code, and every time I open a file in the data folder, I'll have to open ... move up one, /data, go into data, / whatever my file is. So I want to get you accustomed to that. Now here is where we're going to start grabbing data from the weather channel place again, but instead of doing the mean, the sum, and all this, we're going to graph the data. So now we're taking our first steps into visualization. All right, so part 3. Line 80 imports requests. Question?
No,
Oh, okay. Sorry. Import requests. Now this is important because Ramesh imported requests earlier. So why do I have to do it again? It's because IPython Notebook and Spider are 2 different ways of working in Python. If you do something in IPython Notebook, doesn't mean it actually does not mean that it happened in Spider. So in Spider, I have to import requests again. So what does request do? Does anyone remember? What does it get? It goes to the internet. It doesn't have to be APIs. It can just go to the internet. That's the cool thing about requests. And there are people out there whose job it is. They're usually called they're not web developers. They're the nice term is web analytics, but it's another term for scraping. Scraping is this idea that you can go to any web page and just take the HTML and the data from it. It's not against any terms of service unless the website says, please don't scrape our website. So big companies like LinkedIn, Google, Twitter, they have in their terms of service that everyone reads so intently, please don't write Python scripts to scrape our website. So what do they do instead? They offer APIs so you don't have to write scrapers. Now, OpenWeatherMap are very nice, and they made a very simple to use API just for the sake of getting data easily. In fact, I've worked in other classes, we've worked with this before, and I've spoken with the people at the company, And they gave us permission to, like, we once asked, hey, can we just have all the weather data for everyone in the world? They're like, yeah, sure. They gave us open access to all of the weather in the world for a month and say, yeah, just after a month we'll stop it, but for the remainder of your class, go for it. So they're very nice about giving you data. Very nice about it. Okay. In lines 81 through 86 is very similar to what Ramesh was talking about, or with the actual ID and the getting the temperature, the humidity. What this is going to do, I'm going to run it. I made an object called request. So in line 89, I look at request. Now it's telling me request is response 200. Now, that might not mean anything to you, but you know what means something to you? 404. Is anyone familiar with 404? What does 404 mean? And wasn't found. You know what the opposite of 404 is? 200. 200 means A-OK. You got this website just fine, and everything went just fine. So when you use requests, you're making a request object. The request object will tell you the response, 200. Now I'm going to try to make a point here. In my console, I'm going to request.get LinkedIn.com. And it's going to give me that. Okay. Now, you don't know who Dave McClure is? Founder of 500 Startups, the venture capital firm, Hopkins alum. That's his LinkedIn page. LinkedIn.com/in/Dave McClure. I just tried to tell requests to go there. And look what it told me back. 999. That's a not happy sign. That's LinkedIn's own personal message saying, stop scraping us. And for those of you who have tried this before, if you try to use any kind of scraper engine to run on LinkedIn, they will give you a 999, not a 200 saying, stop it. They won't let you. So this is kind of makes a point, but that's why LinkedIn offers an API. That's why Twitter and Google offer an API. Because people like us can make this software to go to millions of LinkedIn profiles at a time really fast. So what do? They stop you. Google is a little nicer. You can actually scrape Google 50 odd times in 2 minutes, and then they'll block you. But that's a good amount of times. Bing doesn't care. Bing is like, oh, please come to Bing. I don't care what you're doing. Just come to Bing. Bing totally doesn't care. It's funny. Okay, so request is our API. I'm going to look at the text. Now, we've already seen this before. Oh, it's those dictionaries. Fine. But they're actually not dictionaries. They're called JSONs. JSON stands for JavaScript Object Notation. All that means is it's just the string representation of a dictionary. So if I were to write down a dictionary on a piece of paper and give it to you, that's a JSON. It's like a literal written representation of a dictionary. Luckily, the request module has a function to extract JSON from an API. So here I've just made a variable called data. And this should look very familiar. It's the same data we were looking at before in the IPython notebook. So we have the keys method of dictionaries, and the keys method just gives us a list of all of the keys. So when I call this function, it gives me the city, the message, the list, the COD, and the CNT, the count and the coordinates of the city. What city did I choose? Istanbul. Bonn City. Here's coordinates. Right. Country Turkey, ID 745044, that's just the OAPI's ID for Istanbul, and Istanbul population, 11.17 million people. By default, it gave me 39 values. Data list is the list. So the list is actually, every 4 hours, it gives me an updated temperature, humidity, wind pressure, wind speed, wind direction, all of that. So right now I have about a day and a half worth of weather data from Istanbul in data list. Now I want to reiterate and make sure we're all on the same page. Data is a dictionary. Data is a dictionary. data list, list is a key. The value of the key list is the literal list of weather objects. So in Ramesh's IPython notebook, we were working with San Francisco, Baltimore, the Austin. We had the temperature and all that. Here is just Istanbul, but we have 39 of them for Istanbul over a period of time. All right, pop learning opportunity. How many items are in this list? I said it already. 39, right? Oh, I have it down here. Answer, Len. Oh, 36. Oh, you know what? I ran it a couple hours ago, 36, and now it's 39. Well, you live and you learn. What is the first element? It's just one of these. One of these, the weather object. Clouds, all, date time. Does anyone know what this number is? It gives me date time in a number. Why?
Unix time.
Unix time, otherwise known as epoch. Epoch time. What is epoch time? It is a Unix time or epoch time is a standard of telling time, and it literally tells you the time in a very large integer. Do you know what that very large integer means?
Seconds since 1970.
Yeah, it's the number of seconds since January 1st, 1970. Midnight. UTC. GMT, sorry. It's the literal number of seconds since January 1st, 1970, midnight GMT. Yes, yes. I don't know why. I don't even know the story, but that's what that number means. Why do we do that? Because time zones are annoying. Time zones are annoying, but whether I'm here in Baltimore, in Istanbul, we've all, humanity, has experienced the same number of seconds since 1970, January 1st, midnight GMT. So it's a way of, if I give this time to someone, they can convert it to their own time zone, but it's synced up. So using Unix time, we can sync up the world's computer clocks. That's why we have it. Okay. That data list, the list of 39 weather objects, I'm just going to go ahead and give it its own name, weather data. So now weather data is the same list of weather objects, I just gave it a name. So using a list comprehension, move this a little bit. Using a list comprehension, right here, 131, hopefully, I didn't change anything. Line 131 is a list comprehension. I'm getting some nods. Temperatures is me taking the temperature from each weather point. So for data points in weather data, the data point's main temp. And this should look familiar from the IPython notebook. So for each data point is itself a dictionary with the humidity, the temperature, all that. Data point main temp is the temperature at that time. So when I run this line of code, temperatures is now the same length list, 39, but just temperatures in order. So I can find the average temperature by adding them all up and dividing by the length. So in the last 39 data points, the average was 21 degrees Celsius. You Americans. I was born in Connecticut. Not even. Range of temperatures is the min, comma the max. So the average was 21, but the lowest it was 18.38, and the highest it was 23.21. So just basic statistics. Here, I do the same type of list comprehension, but for dates. So now I have all these Unix times, which are nice, but I'd rather see them in like a normal date time format. So what I'm going to do is I'm going to import a datetime module. Now here, I'm saying from datetime, import datetime. This is not a pet peeve of mine, but the datetime module, inside of it is a datetime object. They named it the same thing. So to get it, I have to do from datetime, the module, import datetime, the object. So it's kind of a pet peeve of mine, but now we have use of this object called datetime that somebody else wrote for us, that we don't have to. And in yet another list comprehension, for each of those Unix times, I'm going to convert that Unix time into a date time. That's more readable for me. So now dates looks like this. Date time, 2015, 6/22/14. So you can see, here's the year, month, day, time.
That's our.
Hour, sorry. Wow. Okay, I was like, wait, it doesn't make sense. Month, year, month, hour. Why am I crazy? What's today?
Year, month, day,
Yes, thank you. Okay. I'm crazy. So now we have dates and temperatures. Let's plot them. Did you want to say something,
No,
Ramesh?
that is a forecast temperature. That is what 6/22.
Yes.
7-day forecast.
Yeah, this is a forecast. That's why I was confused. Like, wait, what's today? So let's plot it. So we're going to use the matplotlib. And line 157 does a very basic plot. This is what happens when you just say plot dates versus temperatures. Looks kind of cool, but there's no title, there's no Y label, there's no X label. All the date times are kind of smushed together. It's kind of hard to read. But it gets the point across. I'm seeing the temperature go up and down as time goes on. Fair enough. But let's make it a little prettier. So here I'm going to give it an X label, time. Here I'll give it a Y label, temperature in Celsius. I'll give it a title, the temperature in Istanbul. I'll get the X tick marks, and I'm going to rotate them by 70 degrees so they're not squished together. And then I'm going to plot it again. So when I run all of these lines of code, I get the same graph, but now my X labels are now slanted or fit nicer. I have a time, temperature, a title, so it's a little nicer to look at. Python isn't the visual tell-all, end-all software, but it does make very quick plots very quickly. And with only a few lines of code, we can format it to be decently showable. So now we're actually watching the time go, the temperature go up and down as time goes on, and everything is making more sense. Question?
So you're going to copy that to PowerPoint?
Yeah, it is a PNG. You can right click and copy the PNG.
Yeah, so there's a plt.save thing, and it just saves as a PNG.
Yeah, you can
Yeah.
flip over as well.
Bless you. Now that's temperature, but there's also humidity. Humidity, I'll get the same way I did the temperature. Data point, main, humidity instead of temp for data point in weather data. So now humidity is a list of humidities. Humidity index. It's very humid in Turkey. It's very humid in Turkey. It's not fun. Now what we're going to do, though, is we're going to plot both humidity and temperature in the same graph. So in lines 173 through 175, here's what's happening. I'm going to create a legend. The legend will show us the difference between one line and the other, so temperature versus humidity. I'm going to plot dates, is my X, comma humidity. And the label for the legend is humidity. The second line, I will plot dates, same X, comma temperatures. The marker, it'll be very clear in a second, the marker is what kind of symbol you want for each point. The line style is exactly what it means. What kind of line do you want? This means dotted, dashed. And what color? Red. And the label for the legend will be temperature. So when I run these three lines of code, that's exactly what I asked for. I asked to plot temperature versus humidity. Where's the legend? And the legend should be, where's the legend? I think, yeah, it got cut off, but I guess it's kind of the point. So the problem here is what? Would you show this graph to your boss? No. Why? What's wrong with it?
Most of the data doesn't have
So how else would you put that? I want to say.
The scaling is off.
The scaling is off. Here, I mean, this is exactly what I asked for. In Celsius, it's in the 20s, but the humidity is up here in the 90s. The scaling isn't right. So there are many ways of normalizing data. And down below, it's pop learning opportunity answered. Here it is, yay. To normalize it, I'm going to take each temperature and divide it by the max. So the max temperature, if it's 25.11, a data point of 24 is now 24 divided by 25.11, which is 0.956. It's a way of turning everything into a scale of 0 to 1. So now humidity is not in the 90s, it's now in the 0.90s. Now temperature is not in the 20s, it's also on a scale of 0 to 1. So these lines of code create two new lists: temperatures normalized and humidity normalized. Humidity normalized does the same thing. It takes each humidity and divides it by the max, which is 100. So now if I run that again, that's looking a lot better. Because now they're both on the same scale. Both temperature and humidity are now on a scale of 0.8 to 1. And it's easier to see, or not see, a relationship between the two of them. You can kind of see, watch the temperature go down, and humidity follows. So you can kind of see how they're kind of playing together. So, and that was impossible to see in the first graph because the scaling was off. Question? Yeah.
So, I'm sorry, the bottom keys, the times, are they going up like normally? Sorry, in the actual graph.
Here?
Yeah, it is going up, but Matplotlib tries to be smart on how it prints time. So that's why, it doesn't just print the time, it actually puts date and time and just messes up what you want.
Yeah, it's the correct time. It's just not showing you the date times in between. So it just looks a little weird, but it is in order of time, yes. So both of these are in order of increasing time.
Do you know why the graph is still cut off?
Good question. So it's actually not cut off. You mean here?
Yeah.
That's a good question. It's actually not cut off, and she's pointing to around here. What's happened is it hit 100, like 100%, and then it stayed at maximum humidity or maximum temperature, and then it went down, and then it went back up to the maximum again. So it's actually not getting cut off. It's just that's the max it's allowed to be. Because when you divide everything by the max, the lowest it could conceivably be is negative. It could be a negative, but in this case, the temperature would only be about 0, so it would be a 0. And the max it could ever be is 1. So this is one way of normalizing data. There are other generally better ways of normalizing it, but this is a just fine way for visualization purposes. And it allows us to see, I think it's a pretty interesting, you can definitely see a pattern as they move together. I think it's really obvious. Now we can also do a scatter plot. plt.scatter, this is a scatter plot of temperature versus humidity. Now there's no discernible pattern, or is there? So the point of this data file, this Python file, was really just to familiarize you guys with how do you grab data from the internet? How do you parse the data? Parsing was taking the temperature, taking the humidity, taking the Unix time, converting it to normal date time. Because Unix time is weird to look at. What time is it right now? 11,400,000. It doesn't work. It's easier to convert it to normal people time. That's what I call it. It's a technical term, normal people time. And then here, doing a scatter plot, temperature and humidity. This is our first step to trying to look for relationships, correlations. Starting next Monday, when we use more advanced tools, these correlations become much more obvious and much quicker. Okay. Are there any questions, general questions, about what it is that we've done today? And I'm going to reiterate it in case you forgot. What we've done today, today's aim, my goal for today, was to get everyone familiarized with the level of Python and the level of instruction and the level of work that we're going to be doing in this course. That's not to say, again, if this was all over your head, that's not to say get out now, you're not going to do well. That's not what I'm saying at all. What I'm saying is, if you are willing to come to class, to listen, to participate, to raise your hand when I ask a question, and ask questions when you have one for me, if you are willing to put in the work, this coding will come naturally to you. I honestly, I promise that. It's not even like, I think it will. I honestly promise that. If you take the time to look through the code, look through the resources that we give you, look through the labs that Ramesh and I created for today and the solutions that we're also going to be posting by this weekend so you can have some time to do it yourself. If you take the time to look at all of this stuff, Python will come naturally to you. And next Monday, we'll start the class by talking about data science. We'll actually start talking about what is data science, how do we perform data science. These are the tools that we're going to use in Python to perform actual data science. And that's what we're going to be starting. So if you still have questions on Python, please come to office hours. Please use those resources. Please ask a classmate. If you want me to sit down with you one-on-one and go through this code file again, I will. I will honestly do that. I want everybody in this class to succeed and get something from this course. We will be getting into machine learning. We will be getting into cluster analysis, recommendation engines. We will be doing all of that. Trust me, we have 60 more hours left of this class. We have a lot of time left. But this is necessary to get everybody up to speed. So again, if you are getting a little confused by some of the syntax, find one of us, look through the resources. Now, as for next class, at the bottom of the GitHub repository, the SF.15 repository, which is loading very quickly. Yeah. So the Python exercise is another piece of code that I wrote with questions. Please import the drinks module and give me the third column. That's what I'll be posting solutions to by the end of the week so you can actually look through the solutions. The project page is a description of the project of this course because a first draft will be coming up in the next 2 weeks. Why is it so slow? Here's a link to some projects from past data science courses to get an idea. And here, guys, here's the resources that I just mentioned if you still want to look through more stuff for Python. So I do recommend you look through them if today was a little bit confusing some of the syntax. Okay. Are there any questions? Yes.
If we make changes to the Python notebook and then if we wanted to like save our notes, if we did the git pull again, would that erase all the notes that we made?
Good question. No. Short answer is no. It's because we're not going to be changing the file starting now. So when you do a git pull, it's going to look for the files that have changed. And because we're not changing the actual IPython notebook, yours will be unaffected. Now, Ramesh was talking about, well, if you want to be absolutely sure, you can always transfer them over to your repository. So you always have access to it whenever you want in the cloud. But short answer is no. Short answer is, I forgot the question. But short answer is, if you save it and do a git pull, you'll be fine.
Okay.
Yeah. So whatever yes, no answers your question in the affirmative. Any other questions? And I will be staying after class to answer any more if you have any. If not, I will see you next Monday. You can expect this, and I'll post it in Slack. I'll make a class videos link. You can expect this hour of video to be on there, and for each 60 hours to also be in the Slack videos as well.